Mars is the fourth planet from the Sun and the second smallest in our solar system. Despite being about half the size of Earth, it's the most Earth-like planet we've found so far. Its proximity to Earth, about 54.6 million kilometers at its closest, makes it an attractive target for missions. Mars offers the possibility of understanding not only the history of our solar system but also the potential for life beyond Earth. Mars has long held a place in our collective consciousness, influencing art, literature, and cinema. Mars has long held a place in our collective consciousness, influencing art, literature, and cinema. Mars has a thin atmosphere composed mostly of carbon dioxide, with traces of nitrogen and argon. The atmosphere is about 100 times thinner than Earth's, making the planet much colder. Average temperatures hover around -80 degrees Fahrenheit, 60 degrees Celsius, but they can vary significantly depending on location and time of day. Mars' surface is a mix of craters, volcanoes, valleys, deserts, and polar ice caps, presenting a diverse landscape that tells the story of its geological history, mountains, valleys, and plains. The planet is home to the largest volcano in the solar system, Olympus Mons, which stands about 13.6 miles 22 kilometers high. It also has Valles Marineris, a canyon system that dwarfs the Grand Canyon, stretching over 2,500 miles, 400 kilometers. Presence of water. Evidence of water on Mars has been one of the most significant discoveries. While liquid water can't exist on the surface due to low atmospheric pressure, there are signs of ancient river valleys, lake beds, and mineral deposits that only form in water. More recently, researchers found evidence of briny liquid water beneath the planet's surface, fueling speculation about the potential for life. The exploration of Mars began with flybys and orbiters, starting with NASA's Mariner 4 in 1965. These early missions provided the first close-up images of Mars, revealing a barren landscape that dispelled earlier notions of Martian canals and civilizations. The real breakthrough in Mars exploration came with the deployment of rovers and landers, from Sojourner to Perseverance. Mars may have been habitable billions of years ago, when it had a thicker atmosphere and liquid water on its surface. Scientists have found signs of ancient microbial life in the form of fossils in Martian meteorites that have landed on Earth. However, these findings remain controversial and are still the subject of ongoing research. The first successful rover, Sojourner, landed in 1997 as part of the Mars Pathfinder mission. Since then, NASA has sent a series of increasingly sophisticated rovers, including Spirit, Opportunity, Curiosity, and the most recent, Perseverance. These rovers have conducted geological assessments, searched for signs of past life, and tested new technologies for future human exploration. Technological challenges and triumphs. Each mission has faced unique challenges, from landing on the unpredictable Martian terrain to dealing with dust storms that can last for months. Yet, each success has brought us closer to the dream of one day sending humans to Mars. Today, missions like the Mars 2020 Perseverance rover are equipped with tools to search for signs of ancient life directly on the planet's surface. The hope is that future missions, possibly even those involving human explorers, will finally answer the question, are we alone in the universe? NASA has been at the forefront of planning human missions to Mars. The Artemis program, which aims to return humans to the Moon, is seen as a stepping stone to Mars. The goal is to send astronauts to Mars in the 2030s, with a focus on long-duration missions that will test the limits of human endurance and technology. While the dream of living on Mars is tantalizing, it comes with a host of challenges: radiation exposure. Mars lacks a global magnetic field and has a thin atmosphere, leaving it exposed to high levels of cosmic radiation. This poses a significant risk to human health, requiring advanced shielding technologies and habitats that can protect astronauts. Psychological and physical impacts. Living on Mars would be incredibly isolating, with long communication delays and no possibility of a quick return to Earth. The psychological effects of such isolation, combined with the physical challenges of low gravity, could have profound impacts on the human body and mind. SpaceX, led by Elon Musk, has set ambitious goals for Mars colonization. The company's Starship vehicle is designed to carry large numbers of people to Mars, with the long-term goal of establishing a self-sustaining colony. Musk envisions a future where humanity is a multiplanetary species, and Mars is the first step in that journey. The involvement of private companies like SpaceX marks a new era in space exploration. By collaborating with NASA and other space agencies, these companies are accelerating the timeline for Mars exploration and bringing innovative technologies and approaches to the table. The next decade promises to be exciting for Mars exploration. NASA's Mars Sample Return mission, set to launch in the late 2020s, aims to bring back samples from the Martian surface for analysis on Earth. Additionally, new technologies like nuclear propulsion and advanced life support systems are being developed to make human missions to Mars more feasible. As we look to colonize Mars, ethical questions arise. Should we terraform the planet, potentially altering it forever? What responsibilities do we have to protect any potential Martian life forms? These questions will need to be carefully considered.